Hello, my name is Alex Amancio, Creative Director for Assassin's Creed Unity. With a redesigned new game engine and some revolutionary thinking from our engineering and design teams, we've created an experience materially different from anything we've designed before. With Unity, we've raised the bar in terms of how we build worlds and how you interact with them. Unity is a truly immersive experience, revolutionized by new-gen technologies that affect the user's experience at its core. Welcome to Paris at the height of the French Revolution. When you enter here, you'll see what our new Anvil game engine has made possible. It's in the light and in the shadows. It's even in the air. Advanced reflection mapping, HDR graphics, and volumetric lighting in fog fill each scene with drama and intensity. We've built Paris's iconic landmarks for you to explore. At a scale of nearly 1-to-1, these immense structures are not facades. Each is a fully realized creation, a world unto itself. Amongst them is Notre Dame de Paris, a triumph of digital architecture that required a full year to design. These seamless exteriors and interiors are massive, yet intricately detailed. And our next-gen engine brings non-player characters alive in a way never before possible. You'll interact with thousands of Paris's inhabitants, from kings to paupers, each rendered with startling realism and each alive in their own way. These crowds can provide you with valuable cover as you explore the city. But beware, even non-player characters have minds of their own and may not behave as you expect them to. Because of the Anvil technology at the heart of the Unity experience, things not only look different, they feel different.
We wanted to create an engine that was capable of creating truly next generation of AAA games. But we also saw that as games were getting bigger, so were the projects working on them. And we wanted to go better, not bigger. And we all wanted to be smart and not rely on brute force. The engine should also support how we work in the studio, which is a lot of quick iterations on features, have a lot of creativity, and the freedom to experiment and prototype.
The core of the Snowdrop engine is a node-based scripting system. This is really the beating heart of the engine that allows us to do what we do. It affects all systems of the engine, from rendering to AI to mission scripting and the UI. It allows us to quickly develop our assets and to preview them and interact with them in ways that have never been done before in the industry.
It's so easy to use and to set up that you really have the freedom and time to explore different options.
The editor is basically just a set of different windows that you can move around whatever you want. And if you work in a specific way, you can adjust the editor to fit your needs.
Working with the engine is kind of like solving a puzzle, because the components are usually already there. It's just a matter of how you combine them together.
You can do whatever you want. It's like Lego, because it's just different building blocks, and you can test, does this fit here, more or less. You can make some really cool results just by very simple components. I really enjoy to work with it.
I'm Bruce Stull, CEO of Euclidean. Later on in this video, I'll show you our newest work in the area of computer graphics. But first, let's do a bit of a build-up to it. For over 30 years, humanity has been working towards lifelike computer graphics. Thousands of people, millions of hours have gone into pushing your computer graphics towards the goal of lifelike real-time 3D. Graphics are nearly there when it comes to movies that were made on giant render farms. But for real-time graphics on our ordinary computers and games, there's still a lot of work to do. Real-time graphics today lack the millions of subtleties of lighting that make them believable. They don't have the computer memory to make everything unique. Our eyes pick up on the repetitious copying, and they're limited in the amount of detail they can display. Today's games look really good, as games of every year always have done, but do they look real? When we have a look at video clips like this from the real world, we immediately know it's from the real world because every element of the lighting in the scene adds to all the other elements that come together to give an overall combined effect that is extremely hard to mimic. Computer graphics are made of little flat polygons, whereas the real world is made of atoms. So the real world gets subtle details on every texture that a flat cardboard polygon just can't show. Looking at the time, I've apparently used up 1 minute and 20 seconds of this video, and according to YouTube statistics, I've only got about 1 minute and 40 seconds to show you something really interesting and get your attention before the majority of you decide you're bored and you move on to some other video that's a lot more interesting. How inefficient of me to use my time showing you video clips of all these nice real-world places we filmed when we should have been showing you some amazing new lifelike computer graphics. And now I've only got 5 seconds left to amaze you, or apparently the majority of you will be gone. Well, what if I told you that what you've been watching are not video clips from the real world at all, and that these scenes are in fact Euclidean's current level of real-time computer graphics? For those of you who don't know Euclidean, in 2010, we found a way to give computers unlimited graphics power. And then in 2012, we abolished loading and made it so the graphics don't have to load the model now, they can run straight from terabyte hard drives. A lot of professionals on the internet said that our claims were impossible, but they were wrong, and now our technology is being used by some of the world's biggest companies. So we built a technology that takes laser scan data, upgrades it, enriches it, remodulates its color by compounding different values from different angles, compresses it down to make it use little memory, and then we stream from the hard drive or over the internet. This is the result. Regarding the question, will this technology be used in games? Yes, Euclidean is working on 2 games that use solid scan technology. Yes, we can do animation, and yes, it's very good. But that will remain hidden away until our next video. Thank you so much for watching this video, and thank you to all of you who've written such encouraging emails to us. Euclidean's goal is to bring next decade's technology to today's world, and so far things are going according to plan. I hope that our work can bring some enjoyment to your lives either now or in the future.